great pleasure to introduce our speaker this evening, Dr. Kari Nadeau from Stanford University. I've actually known Kari for a very long time. I first met her when my very first graduate student at Harvard Medical School became her husband. I won't say anything about him. But I've known Kari for a long time. She did her undergraduate work at Haverford, then went on to the Harvard Medical School in the physician scientist training program. After that, she did her residency in pediatrics at Children's Hospital, and then took a brief detour into industry, worked at Biogen for 4 years in Boston. And actually I got to hear from her husband how she would get on the Concorde and fly to Paris for lunch meetings. Back when we had the Concorde, and then she'd come back. She told me she was pregnant when she did that too, so that was particularly interesting. After Biogen, she moved to Stanford in 2003, where she did a fellowship and a postdoc in asthma, allergy, and immunology research, and eventually was appointed to the faculty there in 2006. Now, the story today comes through a bit of serendipity, as a lot of science happens. It was in March of 2013. My wife had gone to the store. She'd come home with the New York Times, which who has time to read a 10-pound newspaper, but it makes a great fire starter. But the one thing that I heard from the kitchen as my wife was looking through it was she pulled the magazine out and says, "Oh my God, this is Kari." And on the cover of the New York magazine, it says, "What these kids just ate could kill them. So why are they smiling?" And then it says, "Because one heroic doctor is learning how to protect children with severe allergies." And that's what really Kari has been doing for the last several years of her career. She's really been pioneering initially the use of oral immunotherapy to treat single food allergies. There's a great story in this magazine that really sums her up, at least as I know her and as she is as a person. A young mother had been traveling back and forth across the country trying to find a treatment for her daughter who had multiple food allergies. And every doctor she went to said, "Forget it, nothing you can do, just keep her away from all this stuff. Keep her away from food," basically. And she met Kari at a talk at Stanford, and she asked, "Is there anything I can do for my doctor?" And Kari very characteristically said, "I'm going to figure this out for her." And she began thinking, is there a way that she could use this oral immunotherapy to treat multiple allergies at a time? Whenever you come up with a new idea in science, or pretty much anything, the likelihood that you're on the right path is always directly proportional to the number of people who attack you multiplied by the vehemence. And nobody liked the idea. They wouldn't fund her, they wouldn't pay any attention to her, they wouldn't collaborate with her. And truly, as I know her, she said, "The hell with it, I'll just go do it myself." She even went so far as, in trying to raise the money to do this research, these trials, went so far as not taking a salary for 3 years. And as she points out, her husband, my former graduate student, was not very happy about that. But it does indeed reflect the kind of phenomenal commitment she has, the pioneering spirit, the willing to absolutely buck the status quo, which you have to do if you're going to change the world and make a difference. And it's a great pleasure to have her here. She's going to talk to me about her the stuff she's been doing at Stanford the last several years. Welcome.
Thank you. It's an incredible pleasure to be here, but in all humility, Kevin and Becky are incredible people, and if it wasn't for their inspiration when my husband was in graduate school and being able to go to their house for dinner and enjoying the pleasure of a faculty member really taking us in and being a wonderful mentor, I don't think I would have had the comfort level and the confidence to be able to move forward. And there were a lot of great mentors in the story I'm going to be able to tell you today. But most importantly is I'm so thankful to be here and on this beautiful island and to have the pleasure of speaking to you. And I want this to be an interactive conversation. Many of you might or might not be connected to someone with food allergies. This is on the rise, and we'll talk about that in a minute. But importantly is after my talk as well, we'll have a lot of time for questions. This is a burning issue in a lot of people's minds. It's global. I talk all throughout the world. Just talked in Norway, talked in Korea, talked in Turkey. Lots of people are dealing with this issue, and so we're talking about it tonight locally. But any questions that you have, I'll be very happy to talk about them and try to answer them. But we're only as good as our research allows us to be. So just a quick show of hands for how many people have food allergies or know of someone with a doctor's diagnosis of food allergies? Okay, so, and that might be a slightly biased population because you're here tonight. However, it's increasing. There are a lot of people that are dealing with food allergies. There's a ripple effect in society because not only does it affect that child or that adult, but it also has a ripple effect on their social situation and their schools and their camps and what they can eat and what they can't eat. And since food is such an integral part of our society, this type of disease is really affecting not just the person, but also all the people that they interact with on a daily basis or not. So at Stanford, I have a great group of scientists. You know, when my husband was at Harvard Medical School, he had this amazing poster on his wall. And I grew up in the East Coast, so I was born in Exeter, New Hampshire. I'm from New Jersey. I had never ventured past basically the Mississippi River until I was 30. And so he had this beautiful poster on his wall, and there's this place called Stanford. I thought, Stanford, Connecticut doesn't look like that. It's got these palm trees and this beautiful place. I thought, what is that place? And do you actually even study there? So apparently you do, and I've now confirmed that because it's a great university. I'm really appreciative of the scientists that I work with, and a lot of what I'm going to show you tonight is a team effort, not just me, but all the people that I work with. And now we're creating a network alliance around the globe, and I'll talk about that as well. And my lovely daughter is here tonight, Stephanie, and she's going to be helping out as well as part of that team. And we have quite the group at home. Stephanie has 4 other siblings as well. So Paul and I did a lot of work after graduate school. And I will continue with the slides. So thank you, Stephanie. So I'm going to talk about this new approach. And Kevin is right. We did have to buck the status quo to be able to get where we are. But that's OK. And we're moving the needle forward. And we have to make transformative changes because life is short. And we need to be able to help people and families that have this disease. Next slide. Thank you. So let me just pull the audience a little bit as to what is food allergy. For people that raised their hand and said you have a food allergy, do you mind if you can share that with the audience, what food allergy you have? Yes?
One of the most tragic food allergies is to peanuts.
Yes.
Peanuts are almost everywhere, and it's a tiny percentage of people who are allergic, but they can be fatally allergic. And I have a couple of times, I'm a physician, been on an airplane where someone ate a peanut and said, oh my God. And happily, their crew had some of the wonderful stuff that you give them to eat. But and then genomics, we'll talk about that later, I'm sure. But when you understand food allergies and you understand genomics, you may be one step along the way.
Yes, absolutely. So about 1% of people have peanut allergies, and of those people that have peanut allergies, 94% will have a near-fatal anaphylaxis at some point in their lives. So, and nuts can do that. Shellfish and shrimp, since we're here, can also do that. Some food allergies develop in childhood. Some food allergies develop in adulthood, interestingly enough. But what is not a food allergy? I think that's really important. It's not a headache when you eat Chinese food. It's not a stomach ache. It's not bloating. It's not diarrhea alone. Most food allergy is related to a reaction in the immune system that deals with chemicals called histamine. That's why antihistamines sometimes help, but not always. And it can be within 6 minutes, but as long as 2 hours after you eat the food. If you haven't eaten food for 2 hours and you have some kind of reaction, that's probably not a food allergy. Does that make sense? Yeah.
What about sneezing?
Sneezing, I have seen it, but it's rare for foods. But you usually get mucus congestion and allergic rhinitis, and that's about, I guess about 10% of our patients have had sneezing with it. But you can definitely get it. So it's all or nothing for that individual. So you can definitely sneeze with foods. And it usually happens within 6 minutes to 2 hours after eating that food. Does that answer your question? Okay, great. All right, next slide. So if we ask the general population, do you have a food allergy? What's really interesting, and we've done this, is we ask questionnaires out to a lot of people. 20 to 30% will answer yes. If you ask my son, who's 15, do you have a food allergy? He'll say absolutely to green beans, broccoli, to peas, anything green, anything green. But the problem is that I'm a food allergist, so of course we have ways to test this. But there are a lot of people that think that they have food allergies, but they're just intolerances. Some people really can't tolerate wheat that well. It makes them bloat. It makes them feel uncomfortable. And that might be a gluten sensitivity, but it's not going to lead to a near fatal reaction. So if you actually see who has doctors diagnosed food allergy that could lead to a dangerous reaction, that's about 3 to 4% of adults and about 6 to 8% of children. Now those numbers are worrisome. They're doubling every 10 years. So in the United States, there's about 18 million people that have food allergies. And that's a doctor's diagnosis of food allergies. And I had one patient who was about 55, and he'd say, yeah, I'm allergic to peanuts, but I'm not too worried because every time I have a peanut allergy, I just feel a little tingling in my hand. And so I just kind of be careful. But the problem is that if you have a doctor's diagnosis of food allergy, you have a 25% chance at some other point during your life of having a full fatal reaction or near fatal reaction. Just because you have one type of reaction one day does not mean that that's going to be the same reaction you have on another day. Same dose. Because viruses, heat, other things that are going on in your body have an effect on how you're going to react to that protein. All right. Importantly is that this number is 6 to 8% of children, 3 to 4% of adults. This is worrisome because there are many adults now, I see in clinic as well as across the United States and other parts of the world, that all of a sudden they'll be going along just fine and then they start to have a food allergy to those things that they could have eaten before. Does anyone have that type of, yeah, what?
Cherries, peaches,
Yes.
plums, apples, pears, anaphylaxis twice.
I'm so sorry.
And hives.
Right. And what's interesting is that they're all related. Your allergist probably told you a little bit about how they're related. But when I was in medical school, I didn't know that cherries were related to plums, that were related to other, what we call stone fruits. Stone fruits are those that have pits in them. And so it's fascinating to see with a little bit of knowledge of botany how closely related some of these items are. And they can be rather dangerous. And importantly is we have to be really careful about it and desensitize. So, and you could have eaten those as a child.
I ate them the summer before I had the anaphylaxis and was 5 days in intensive care.
I'm so sorry. Yeah. Yeah.
It is what it is.
It is what it is. Absolutely. So now the other thing about this food allergy is, and I've had to deal with a lot of principals of schools where, you know, we grew up in a time where I could eat a whole peanut butter and jelly jar, no problem. But unfortunately, all it takes is a small amount of protein. And the way I like to create this analogy is if you have a bee sting here, who has reactions to bees? Right. And how fast can that reaction happen if you step on a bee? Right. And do you do you wheeze?
I always have my EpiPen with me.
Great.
I've been to the hospital.
Right.
So I'm fearful.
Right. And when a bee stings you, does anyone want to take a guess as to how much protein goes into your skin? It's minuscule. Anyone know what a nanogram is? Anyone could see a nanogram? It's nanogram to microgram quantities of a protein called phospholipase. So in a very similar situation, when you eat or you breathe in a food, you can have a systemic reaction. So for people that think, oh, you have to eat a lot of that food in order to actually react, that's not the case at all. I've had plenty of patients where someone is cooking fish in the apartment nearby and it wafts in through the window and they will have a full-blown wheezing and anaphylactic attack. So it just takes in breathing, or it takes in eating, or it takes in, unfortunately with bee stings, actually injecting that substance. But it doesn't take a lot of protein to create this incredible reaction and cause a food allergy. It does take a little bit more protein to create intolerances. But for food allergy, it can take as little as nanograms and as high amount as grams in order to see these reactions. Okay, next slide. All right. Who has done these wonderful skin tests? Okay. For aero allergens and food, or just for environmental allergens? Food? Environmental? Okay. Okay. And did anyone think that they were a little bit on the draconian side, or a little bit of a blast from the past, or no? I mean, what we're doing there is just putting needles into people's skin, right, with the same substance that you're allergic to and just seeing if your skin reacts to it. We've been doing that for 100 years. It doesn't seem too scientific, but let me explain the science. So there are mast cells in the skin, and mast cells are kind of your allergic cells. They are protective to some extent, we think, probably for skin cancer. But for the most part, they're a little bit of bad actors. They like to secrete histamine and this other chemical called bradykinin. And the minute you put the skin test there, they start reacting and they can spread, and your capillaries start expanding, and you start creating this chemical that itches. And so the skin test basically tests the mast cell and how much it's going to react on your skin. It doesn't necessarily say if you're going to react to that food systematically. It just says that your skin's going to react to that food with that specific test. So they're only about 50 to 60% correct. So they're not the best diagnostic test, but it is the only tool we have. And unfortunately, it's the best tool right now. And I'll talk to you a little bit about what we're doing at Stanford. So people use that. Now, they can be as good as 90% predictive, but as little as 50% predictive. It all depends on the technique that's used and what's used to actually give the skin the reaction. There's also this blood test that is done on specific IgE. IgE is kind of like the match that lights the fire. It's this little molecule. It only represents about 0.005% of the total plasma protein. So there's not a lot of IgE in any of us, even people with allergies. But it sure is powerful. And when it's present, it docks onto a cell and then creates this reaction. But it's one of many things that creates the reaction. Unfortunately, probably one of about 32 things. So by measuring it, you're not going to get a perfect predictor of a response either. But these are the two tools that we use. How many of you have had blood tests that relate to IgE? Okay. I won't call on you. I'll try to, I don't want you to have to be the target. So, did anyone from, yeah, great. And do you remember the numbers that were given to you of that test?
By numbers meaning?
What the levels were when they gave you the test, if you want to share? Okay, all right. Does anyone or any grandchildren or any of your relatives have greater than 100 on their test? Yes? Yes? So unfortunately, this test also, once you get over 100, they don't report it out. So it's also not great because it doesn't really tell you with specificity the quantity that you have an allergy to. So it's about 60% predictive. So unfortunately, the only way to really know if you have a food allergy is to actually give you the same food that you think could actually harm you. And that's not a great gold standard. So what we decided to do at Stanford, and at Stanford, all our kids go to school together. So we have 3 elementary schools on campus, we have 1 middle school on campus, and then the high school's on campus. So when all the faculty, we live close together. So when we go to school parties, we all are drinking our coffee together. And so we were basically gathering around one child's birthday cake and saying, why does it have to be made of rice flour? And that's because the child had a food allergy. So we all decided the head of genetics was there, the head of pathology was there, the head of bioengineering was there. And so we all decided that we had to change this, and we had to get our minds together around this. And the next time we met, which was not at the party, we actually put together our thinking caps and did a nanofluidic type of technology to be able to understand how we can get better at diagnosis. So we have 3 patents now that just came out in April, in which you can take 2 drops of blood and you put it in a nanofluidics model, and we're doing flow cytometry as well. And what we look at is all of those cells that encompass a reaction in a whole blood, we now test for their reactivity. And so we're getting measurements of, do you have a food allergy or not? How severe is it going to be? How long will you have the food allergy for? And we can do this as early as a day of life. So the important thing is as you go through life, each time that you test a food allergy, it might be different according to your age. But importantly is that when you do test that at that point in time, you want an accurate diagnosis. You want something that's going to have a positive predictive value. Importantly also a negative predictive value. So if it's negative, it's truly negative. So that's what we've created at Stanford. We're really excited about that. It took about 8 years to develop. But I think, again, it was about this common problem that we were all looking at. And you've got to be inspired and motivated by the problems in the community. And that party stimulated us to think about how can we solve this for that one individual and that one family. But that's what it takes to kind of push the envelope and really not accept the status quo. Because these tests, we have so many better techniques now in molecular biology to get beyond this. And that's what we're doing. And I'm excited to be able to talk about that tonight. And I'm happy to talk to people about the specifics of that diagnostics later. OK, next one. Thank you. OK, so I also want to ask you guys, how common is food allergy? I spoke a little bit about it. Yeah. Yeah. And how many people have heard that it's only in the Western sort of part of the world? That it's only in the U.S. and Australia and the United Kingdom. Right. It's everywhere. Some groups answer yes to that question. But I want to really emphasize that all around the world, this is increasing. So again, it's about 1 in 13 children in the United States under the age of 21. We're only as good as our epidemiology allows us, so more and more research have to be done on the actual numbers. But the numbers in Korea, in Africa, in South America, it looks like it's similar, although we have to get better data. Importantly is that it's across all ages. I have a 99-year-old in my clinic that just developed shrimp allergies, and she's on the go, and she's on boards, and so we desensitized her so that every age can actually potentially get therapy. So that's also what I want to give hope and promise to, is even though it's getting more common, we also need to be able to give therapy to many different age groups. OK, next slide, Steffi.
Is it an injection therapy?
Yeah, I'm going to talk about it, exactly. But not the food being injected. Right. Yeah, that was tried and didn't work so well. Yeah, yeah. FDA.
Why is it more common?
Great, exactly. Yeah, I slipped you that dollar bill really well. Thank you. So, all right, now this is going to be fun. Who has some ideas as to why it is more common now compared to when we were growing up, and what is causing it?
Processed foods.
OK, processed foods, yes? Diagnosed more frequently, OK. Environmental toxins, OK.
Industrialized, because food is prepared in big industries.
Right, industrial preparation of foods, OK. Anyone else have some ideas? Anyone want to talk about microbes? Antibiotics? Maybe? Yes? Yes? Did you want to mention that? Oh, yeah, go ahead. No, put it out there. Boy, this is a very, very educated crowd, so I get a lot of different ideas. Yes?
GMO.
OK, GMO, absolutely. Potential. Yes?
Less exposure to bacteria, microbes, whatever.
Right, right. That's exactly the hygiene hypothesis. Yes?
Is the fact that more babies with developmental disorders are surviving these days into this?
Yeah, interesting. OK, so let me talk about some of these. So if the rate of this quote-unquote epidemic is doubling every 10 years, then it has to be more than genetics. If it was genetic, and even if it was an autosomal dominant disease, you would expect that to occur in generations. But now it's occurring every 10 years, and it's doubling. So there's got to be something in environment. We have done twin studies now at Stanford. I have 2 sets of twins spontaneously. So after I registered for the twin registry in California, the second time I realized someone is telling me something. I better do some research on twins. So since I was getting into the food allergy field, we have these 6,000 identical twins that have been tracked in the state of California, 3,000 pairs. And so we have now, the twins are an incredible resource to be able to answer these questions of genetics and environment. So we have identical twins that are discordant in food allergies. So we can answer some of the questions like, did environmental toxin in one, was it different than this one that didn't get the food allergies? Does that make sense? So you can really test the overlay of environment when you have identical twins. What you can also look at is when you look at fraternal twins, you can say, OK, well, was there something in the exposure in the uterus that might have affected the growing 2 twins, and that had an effect on their food allergy? So we can answer some of these questions. The diagnostics doesn't seem to be the case because, unfortunately, the same tools that we use now we were using 100 years ago. But I do think, to answer your question, I do think that people are becoming more aware of this. So more people are coming to the pediatrician and asking, does my child have a food allergy? So I think people are becoming more aware of it. But we think the doubling every 10 years has to be multifactorial. It's probably something to do with the fact that we are a cleaner society, that people need to be exposed to good microbes. And a lot of probiotic studies have been done. So there seems to be something about the gut. For example, in Australia, there was a period of time in which before women gave birth naturally through their canals, they were completely cleaning their guts out with basically something called physoderm. Does anyone remember what physoderm was? Okay. Not fun. I can't imagine having that done to you. But they cleaned everyone in Australia out before they gave birth naturally, and those children had a 1 in 5 chance of food allergy. So they think that somehow from the mother to the child it's really important to pass good microbes. Now, how important that is we don't know, but we do know that growing up in an environment near a farm rather than in the city is protective against allergies. We do know that if you have an infant and you want to start feeding them foods between 4 and 6 months of age, feed them diverse foods. Don't just feed them one type of food. Feed them wheat, more of a Mediterranean-style diet. Start feeding them nuts right away. Feed them nuts every day. This study just came out in this great journal called JAMA, as well as a big European journal this year. So that's a little bit different from what people had been thinking about previously. But diversification of foods early on is very important. That protects you. Getting good microbes in your gut is very important. Eating a good diet that's not made from synthetically prepared foods, making something that you would recognize or your grandmother would recognize is very important. We do think that processed foods are probably not beneficial to the gut, beneficial to the way that our immune system is seeing these proteins. So the more and more processed foods, we're going to look at those chemical overlays, but we think that that might have played a role in why some of the twins are getting food allergy and why some are not. Tobacco smoke and air pollution are also playing an important role. So there's certain pollutants, polycyclic aromatic hydrocarbons, arsenic exposure also seem to be increasing the risk of food allergy. Yeah, great question. So people did do mercury. They also looked at folate because a lot of women started giving themselves folate supplements after the whole spina bifida rage. There does not seem to be a connection. But we're only as good as our research. So it was only based on about 40 people. So I think that people need to look at this. There's a big national children's study going on at the NIH as well as the National Environmental Health Centers that are going on for children. And we're going to be longitudinally following kids and seeing about whether or not certain exposures affected their food allergy.
Is breastfeeding protective?
Right. Great question. So breastfeeding is protective out to 6 to 7 months. So breastfeeding, no matter what, is better. And we've seen that in the children that have that get breastfed, their guts are also healthier. So in general, so I think it's a great question. And then about genetically modified organisms, that data is really still up in the air. We haven't done randomized controlled trials because it's very hard to do that since a lot of our food is already genetically modified, soy, for example. So it's hard to be in a place in the United States where you could do that trial perfectly. There are other places around the world where we are actually enabling ourselves to test one arm that gets GMO type food versus another arm of a cohort that doesn't. But that's actually happening in Africa. We can't do that here in the United States. The other thing that's worrisome is a lot of the meat in the United States, and the cattle and the poultry have a lot of antibiotics given to them. So we also think that the meat products that we have in the U.S. might be affecting our own guts. And then that might be why some of the reasons why some adults are getting food allergies. But we don't know that yet, and that's why the twin studies are going to be so important. Those are all the causes that we now know of, but that was a lot. So now we need to do the good science to be able to prove it or disprove it. Next. So now let's talk about treatments. You got, how many people carry EpiPens? You carry an EpiPen? EpiPen. Who else has a food allergy that carries an EpiPen? Okay. So, and how fast does an EpiPen work? Anyone have to try it themselves? Yeah. 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 How much epinephrine is in one of those pens? How much? It's the
Enough to get you to the hospital.
exactly. Right, exactly. It's a jolter. It basically has the equivalent of adrenaline of an espresso shot at Starbucks. So it's not an incredible amount of adrenaline, but it does the job, opens up your breathing passages. So the thing that can harm you when you have an anaphylactic reaction are your lungs. So when they looked at all the people that had a reaction that was either near fatal or fatal, and they always happened in the first 2 hours after eating that food, it was all respiratory. It's not the heart. It was all the lungs. Because what happens is when the mast cells that I was talking about in the skin also line the lungs. And again, they're kind of bad actors when it comes to allergy. And so they also stimulate the lungs to secrete lots of mucus. And how big is your airway? Your airway is about the diameter of your pinky.
Awfully small.
It's not. That's right. It's not very big. So when you have an allergic reaction, just like your skin swells up, your skin, the same type of cells, your skin cells line your airways, and so they can swell up, and it doesn't take a lot. And you can imagine for a child, it's even less. So that's why within 6 minutes, someone can completely close off their airways. And you've heard of these horrible stories, and they're true. But the EpiPen is the only thing that can save that life because it's adrenaline, it opens up, and it allows airways to be able to be open, to be able to breathe. If you give yourself antihistamines, it's not really going to stop the reaction. So the important thing is if you're wheezing, you have to give yourself an EpiPen. If you're coughing, has to be an EpiPen. If you feel like your throat is closing, EpiPen. And it's not that hard to give. It's very easy, as long as you don't have a heart condition. Yes?
Why 2 hours? What's the mechanism?
Great.
What's the mechanism
Yeah. So, right. In the signaling cascade, the mast cells act, and then they send their signals to T cells and B cells. And those T cells and B cells, other parts of the immune system, could get activated and drive the signaling system again. And that whole circular process lasts for about 2 hours. But it kind of dwindles down after 2 hours. So we've never seen anyone have a near fatal or fatal reaction after 2 hours after the food. Does that make sense? Because it's basically a dilution of the histamine and the bradykinin. Yes?
What are the symptoms of allergies?
Sure. So let's just go from top to bottom. So your eyes can itch. Your nose can itch and sneeze and fill up with mucus. Your throat can itch. Your ears can start feeling red. You can start having hives anywhere. You can eat the food, and your hive could be over here, for example, because that histamine is going throughout your system. The other organ system that can be affected are your lungs or your gut. Your gut can start cramping down, and you can feel a lot of pain. And the last symptom that we've dealt with is blood pressure drop. So what are the percentage of those? About 80% of the time, it's your skin. It is going to be showing up on your skin, but not always. 8% of the time, it's your abdominal cavity. It depends if you have asthma or not, but if you have asthma, about 15% of the time, it's going to be your lungs. So people who are with asthma also are set up for having near fatal or fatal reactions, so you really have to take care of your asthma. Does that answer your question? It's not a headache. It's not bloating.
How about your esophagus closing so you can not?
Yeah, so there's a different disease called eosinophilic esophagitis, which sometimes is associated with food allergy, and that's associated with scarring of the esophagus, and the esophagus can close off over time. But there's a way to prevent that. Yeah. Okay, so the only known therapy right now is access to an EpiPen or Auvi-Q. There's some new injectable epinephrine devices coming around. There's no definitive treatment that's approved by the FDA yet. And right now, like Kevin said, all we're telling in the past, what we used to tell our patients is just avoid the food. But that's hard. I had one patient who was 21 years old. He wanted to go be a cook at the New York Culinary Institute. And he was allergic to everything except ostrich meat. And it was incredible. This poor man had lived most of his life, and his mom had to cook everything, basically for him outside of this. But he truly was near anaphylaxis to most all foods except this one meat. So that's not fun to avoid all these allergenic foods. And it's becoming more and more of a problem. And the problem also is that a lot of these nuts are contaminants. Now, nuts are terrific for you. If you can have nuts, have them, because the omega-3s, the amazing nutrients in nuts are very helpful. A New England Journal article just came out this year showing that if you eat 6 nuts a day or more, you have decreased rates of cancer, decreased rates of heart disease. So they're actually good for you as long as you don't have a food allergy to them. So in the next slide, I want to talk about what we focused on. So there were enough patients in my clinic where I used to, when I was in Boston, most of my allergy patients were asthmatics. It was all environmental allergies. But then over the past 20 years, I've seen this shift for all my patients in my clinic to being food allergies. And that was before I got into the field. So out of 2,000 patients, about 1,200 were coming into our clinics with food allergies. So it was time to create a therapy. And what was interesting is that there have been a lot of people around the world. There was an Italian group had started this process early on. Colleagues on the East Coast had started this. So we're not the only institution doing this work. Johns Hopkins, Harvard, Mount Sinai, Duke, University of North Carolina, Arkansas, Philadelphia. So what we decided to do that was unique at Stanford was to say to patients, like in the New York Times article, if they have multiple food allergies. So I really wanted to figure out for that child that can only eat ostrich meat, for example, or the child that was in the New York Times article that was allergic to 5 or 10 things, I wanted to figure out a recipe that worked for them. Because there were already other therapeutic regimens around the country that if you had a single allergen, people would be desensitized to it. Very much like if you have a cat allergy, you can be desensitized to cat allergies. So the same thought process happened. And what we decided to do was, number one, we'd have to take all of our patients through actual food challenges. And so if they were allergic to something, we'd have to prove it first before you could actually start treatment. I think the best part of this aspect of our trials was the fact that a lot of people came in thinking they had food allergies, but after we tested them, they were negative. And that's the best way to cure someone, is to figure out ahead of time if you actually have the disease or not. So a lot of people came in, we did all these food challenges to things that they thought they were allergic to or they really were allergic to, and then we started the therapy. But before we gave them...
What OIT means,
yeah,
Xolair means.
absolutely. So before we started the therapy, we gave this medicine called anti-IgE, made by Genentech. I don't work for Genentech, but anti-IgE is Xolair. Xolair is otherwise known as omalizumab. It's been used for asthma for about 20 years, and it's made by Genentech. It's a great drug. It's very specific. It doesn't have any other side effects, which is wonderful. And it protects against having an allergic reaction. OIT is oral immunotherapy. So we link the anti-IgE molecule with oral immunotherapy, which is giving back the same foods that you're allergic to in a stepwise fashion, very safely. If we were just to use oral immunotherapy without Xolair, it would probably take about 3 years to desensitize you. But with Xolair, it takes about 6 months. And that's what's nice, is we can quickly and hopefully, most importantly, safely have a person go up to a serving's worth of food within 6 months. And that's what we're doing at Stanford. So we've treated about 300 people from all around the world. There are people coming in from around the world to just basically park themselves in California for a while. And what we do is we give the Xolair 1 dose, and then we give another dose of Xolair, so 2 doses. And then we start the oral immunotherapy. So you build up the Xolair, you protect the system, and then you start on the first day of food therapy. You start giving about 1,000 milligrams. Now this is amazing because these people had previously reacted to 6 milligrams. So it's almost 200 to 300-fold higher. That's the first day. And then at that day, they can go eat. They don't have to worry about restaurants. They don't have to worry about contaminant levels on food labels. Their life already changes, which is great. And they can fly on airplanes, for example. So that's within 3 months of the protocol. And then after that, we give more Xolair, and we increase your dose so that finally, by the end of 5 months, so this is a fairly fast regimen. At the end of 5 months, you're eating a serving's worth of food. So for people with egg, milk, nut allergies, shellfish, fish, soy, sesame seed, we've developed this therapy, and it's really with a lot of help by the FDA. The FDA has been integral for being able to have something like this developed for people, as well as with the NIH. So we work with people around the country now. We have this trial going on at 8 other sites around the country, so we're very excited to be able to create a network alliance that is doing this in a randomized controlled setting. And then when you're finally done, the big question is, do I have to eat the food every day for the rest of my life? And how much of that food do I have to eat for the rest of my life? So let me talk to you about that. All right, Steffi. So this is data. I'm very data oriented, so you have to forgive me. But for example, the FDA uses a endpoint which is about 10-fold improvement from what you originally could have eaten when you first did your food challenge. And we got up to that endpoint within 3 months. So that's great, but I just didn't want to do what the FDA endpoint was. I wanted to go beyond that and, again, change the lives of these children and adults. So in about 8 months, all of the, what you see in the red line here is that all of the people doing the study were able to get up to 4 grams of food. And what's that? That's about a tablespoon of peanut butter. That's about 2 Reese's peanut butter cups. That's about half of a whole egg. That's 4 ounces of milk. And there definitely seems to be, when you get up to 4 grams of food, you can go much higher. So we also tested for that as well. So that was really exciting for people. Yeah? It blocks the protein reaction, but it's more like a Band-Aid. It doesn't change the immune system, it just blocks it. So the way to change the immune system in a specific way, to change it from becoming allergic to non-allergic to those foods, is to actually give them the foods. If we just gave Xolair, it would just suppress the system to become non-allergic. But what's nice about this is that I take the Xolair off after 5 months, and they keep on taking the food every day, but without the Xolair. So the Xolair is just in the very beginning as a protective cover, and then you take it off because you don't need the Band-Aid anymore because the body is so smart. The body itself becomes desensitized, and that's the beauty of our immune system.
And that works similarly for bee, wasp?
People are trying it now for bees and wasps, but I think the data's not out from Europe yet. Yeah, great question.
So 4 grams is only 1/7 of an ounce. So it's a really tiny amount, but you're saying it would get better.
Yeah, 4 grams.
grams is an ounce.
Right. I guess it depends. Yeah, milk, 4 grams is 4 ounces. So I guess it depends on the density.
4 grams is 28
Yeah.
grams, so that would
Yeah.
be 1/7 of an ounce.
All right. We'll check it. Because it depends on how much protein per volume ratio, right?
So not just the whole food, but the
exactly.
protein part.
So importantly is that each of these when you go and you buy something at the store, you're going to need to be able to figure out how much protein per unit volume is in that substance. And so for milk, it's 4 ounces, a half a cup is about 4 grams of milk protein. Exactly. Does that help everyone? Okay. All right. In the next slide, most importantly is how are we going to know? If people here have gotten therapy for anything, you kind of want to know when you can stop the therapy.
I'm 90 years old and I know when the time is coming.
Thank you. How many people have been on any kind of therapy and you just don't know when to stop it? Yeah, okay. When you're eating the food every day, you can imagine the average 8-year-old, they might like to eat Reese's peanut butter cups every day. Their parents might not like that. Or we have where you have teenagers that don't really like the taste of peanuts, and so they'd like to know when they don't have to take this food anymore. And they've been very compliant, and they get up to measures where they're desensitized. But at some point, you'd like to know, do I have to eat this food every day before I go to college? Do I have to eat this food every day? What if I forget? So we developed a test. So at Stanford, we also developed this diagnostic, which I told you about, which is based on 2 drops of blood. But then we also did a test on what you had mentioned, genomics. So we looked at epigenetics. So epigenetics is a very new field. It's very exciting. We do high throughput sequencing on people's DNA from their blood. And lo and behold, what we did in a very pilot study is we did find a DNA marker that we could track over time to detect who could go off therapy and who needed to keep on therapy for a couple more months. But it's very preliminary. We're very excited. The NIH just gave us some more funds to be able to develop this test, and it's a high throughput test that can be used in any clinic. So we're excited about that, but it's a way to move the needle forward to be able to make transformative changes so that we know who can still be on therapy and who's quote unquote cured and can eat ad lib. So it's exciting, and we've published that. CNN and Nature Medicine did a big report on it in February. So we're excited about that, but this is very pilot data. I don't want to get too much hype about it. Mr. Fisher would not be too happy with these statistics, as it were, because these really just show trends. So we have to be careful, and now we're going to do the appropriate sample size study. Yeah?
Does it ever just not work at all? Like, you know, just like in drug trials.
Right. Great question. So as long as you stay in the study, as long as you're taking a little bit of food, I've never seen it fail. And that's not because we're doing, you know, my job is to keep everyone safe. But what's amazing is the immune system is the talented one here. Because if you train the immune system over time to become desensitized, it is possible, but you have to stay in the program. So unfortunately, if you go too fast, some people have abdominal pain reactions. They don't want to eat the food anymore. So you have to have people stay compliant in order to have success. So that's a lot of give and take. That's a lot of forming an alliance around the family and around the children that undergo these therapies, because they really are the heroes. It's not easy to be a pioneer and be in these studies, but it's important. Yes?
Is there an age that you recommend for a child to start this therapy?
Great question. So right now we're looking at what age is the best. You know, is there an age that's more malleable to do than others? We've done all ages. It really depends on the person and the family. Everyone's motivated. So we now are doing it in 12 months of age, but we don't know the results of that study yet.
And what are your East Coast sites?
Mount Sinai, Philly, University of North Carolina, Boston, Mass General,
Boston Children's?
Children's Boston, as well as Mass General, and did I say Johns Hopkins? No. Yeah, Johns Hopkins.
Your control groups, did they have an allergy?
Right, the control group is here. So the control group that didn't get a therapy is right here, marching forward. They didn't get any change in their DNA.
And they're fine?
And they're still very allergic to peanut, exactly. These are peanut allergic patients that got treated. These are peanut allergic patients that had to still keep taking the peanut every day.
Is this Xolair available, you know, from drug companies, or is it
Great question. So right now, for the use in food allergy, it's just an experimental drug. All of this is still experimental, so we have to do it in the hospital in very safe conditions. But we're hoping Genentech will move and get this approved at some point for food allergy. It's approved for asthma. Yeah. Okay, next slide, Steffi. So it's really important to be able to change quality of life. I can tell people that I'm changing their DNA and their cells, but importantly is what's going on with their quality of life. So you can see here that for people that went in the trial up to 18 months, that we're improving quality of life quite significantly over time. And this mostly has to deal with fear and anxiety and the social implications of having a food allergy and being able to eat out at restaurants, for example. So this is all improving over time, and that's a very exciting result to have as well. In the next slide. So to sum it up, what are we doing to impact food allergy? I think what's key, and you're not really meeting them tonight, is we have an incredible community of moms and dads and children that now are forming support groups for our people that are going through clinical trials right now. A lot of it is community outreach and education. We also are now working with other centers around the world. So we have a site in Israel that will start up, a site in the United Kingdom, a site in Spain, a site in Italy, and then we have sites around the United States, Seattle, Chicago, Cincinnati, Texas. I just talked about the ones on the East Coast. And then importantly is we have this new method that's been patented for diagnosing. We are now looking at this DNA test for managing people on immunotherapy. And importantly is this collaborative work has got to be focused on not only the cure for food allergies, but also the cause. If it's doubling every 10 years, this epidemic is going to be way over what we could potentially all give for therapy. And so the numbers are going to be too high to just keep focusing on treatment. We need to focus on what's the cause and how to prevent it. So we're doing both at Stanford, cure and cause. Those are the two things we're looking at really carefully. And then we really also want to train people. So world-class investigators, we want to bring them to Stanford, train them, and then have them go out to their own institutions to do this work. So I think this is not going to go away. We need to get the best and the brightest interest in these questions so that they can also be talking about here, talking to you hopefully about 2 years to share their data with you. Okay, next slide, Stephanie. So that's my inspiration and motivation. This is another patient who had egg allergies and milk allergies and nut allergies, and now he's doing great. He's able to eat chocolate cake with ice cream, and this is my best result. He's among about 300 kids that we've treated. It's really exciting. So next slide. So what are we talking about in terms of need? How many of you have ever had to delve into the wonderful job of having to apply for NIH funding? Okay, great. All right. Kevin, why weren't Kevin? Okay. So where do we get our funding for all this? 95% of it comes from philanthropy. The other part comes from, and I'm very thankful from the NIH and from foundations. So the fact is 1 out of 20 Americans, children and adults, suffer from a food allergy, 4 to 5%. $25 billion is spent a year on food-related medical care. That's not prevention, as I just talked about. There's no treatment. That's all emergency room visits and days off from work by parents. That's a lot of money. The NIH's yearly budget is $30 billion. In terms of how much is allocated to allergy research, and that's food allergy, just a small portion of that, 18 million. So it's about $1 per person with food allergy. So I think what we all look forward to is that's not the NIH's fault necessarily. I think the NIH has been so supportive and so wonderful about trying to drive the food allergy equation. But it means that as a community, as a group, we really do, in order to make these transformative changes, in order to answer some of the very good questions that came up tonight, we need to be able to have the resources to do that. Okay, the next slide. I wanted to thank you all for your attention, and I can answer any more questions, so thanks.
You spoke about the diagnostic test which you developed, and I was wondering, do you accept blood samples from all over the country, or do these specific centers which you mentioned, are they able to use the diagnostic test which you mentioned? And the second part of the question, if a person has an intolerance rather than an allergy, would that show up in this diagnostic test? And you did not mention anything about intolerances and how to deal with them.
Sure. So diagnostic-wise, the test is at Stanford now. We're licensing it out to 3 potential companies, so we have to keep it at Stanford for now. We do hope that our network alliance of sites will use it as well through this company. So we're still waiting on that. To answer your other question about the allergy testing and whether or not it's related to and whether or not you can get it done at Stanford, you can, if you want. I can work with your local allergist. You can send your blood to Stanford, and we do 90 things with 2 drops of blood. So we do from food to environment to bees to the whole sort of panoply, and to drugs as well. So that's the other important thing is people with penicillin allergies, we also have to diagnose that or other allergies. So we do 90 things at once with 2 drops of blood. And yes, if your allergist is willing, you can get your blood drawn here. We have you sign a consent, and the blood is sent. We can do it within 48 hours of a blood collection. About the sensitivity issue, so I'm really focused on allergy because that's my training, but I'm also an immunologist. And a lot of sensitivity has to deal with other parts of the immune system. And so whenever you test one thing, you should also test the other. It's good science because that's also part of how you test the null hypothesis of a lot of scientific work. So we are developing a test for sensitivity. Actually, the Stanford undergrads are incredible. And so I have 4 Stanford undergrads in my lab that are working on celiac and gluten sensitivity to try to, if I'm getting all this blood from people, let's try to see what allows us to diagnose allergy versus sensitivity. So I will hopefully have better answers to your question soon, but that's exactly what we're trying to do now, is focus our efforts on differentiating the two and why are they different and how could we help sensitivities as well. It's very hard. The people with sensitivities, I don't have good answers for yet in terms of how to manage their sensitivities.
How much can you do with 4 drops of water?
Yeah, exactly. 4 drops. Then you gotta, give me some time. Let's hope no one has that many allergies. Yeah. Yes.
I was wondering if you notice differences between male and female, between ethnic groups, between countries, and what can you use to speculate to generate hypotheses
Right.
that you could then test based
Yes.
on differences?
Yeah. That's one thing we're trying in the twins a little bit. But we do see that first generation families from other countries, when they come here for the first time, their generation, their children that are born here, have the food allergies, but they themselves don't. A lot of people from China, India. So we think there's something in the way that we synthetically process our foods compared to some of these other countries, that the first generation here starts to have food allergies. There are some ethnicities that don't have food allergies at all, like the Pacific Islanders. And so people are studying like why people in Fiji just don't have food allergies. And we think that's because they diversify their children's diets so early. They start feeding them fish and other things and vegetables like within the first 3 to 4 months of age and in very small quantities. So I don't have perfect answers to your question, but we think that ethnicities, there might be a role. We think boys might have a slightly higher increase of having multiple allergies. About 30% of people with food allergies also are allergic to something else. So, so I hope that answers your question. Yes?
There's a great deal of poetry this evening in your presentation. You have touched on superb things that are very important. Now, I want to make a point of one, the halo effect that comes from the NIH. Now, I'm not talking to you because you know this and I know this, but the people here. The NIH has been the source, just like the Nobel Prize, for a long time. If you got a Nobel Prize, then there was a halo around you, and whatever you asked for, you were likely to get. Paul Krugman, you had a Nobel Prize. What has been accomplished by the NIH could be influenced by the rest of the people in this room. And this room is full of very civilized, good citizens. That's my experience with this room. But I would just say that the NIH is a halo. And if you can increase the budget of the NIH, which has been subsiding, we need to increase the budget of the NIH because that has the capacity to make a lot more of this poetry come to life.
I totally agree. I mean, that's fantastic. It took me about 13 years to get NIH funding. And it's, you really have to persevere. You really have to be tenacious. It's very hard to get NIH funding now. But I have, each one of you can write your Congress people. I was on the Hill just 2 years ago pounding the pavement for trying to increase the NIH dollars through Congress. But those appropriations have to be decided by Congress. Yeah. So thank you.
Thank you so much.
Yeah, of course. Thank you.